we have already seen proposition number 18. Now let's look at a remark provided by Euclid as part of, at the end of proposition 18. The remark says, no other figure besides the said 5 figures can be constructed which is contained by equilateral and equiangular figures equal to one another. So the 5 solids that we have seen are pyramid, cube, octahedron, icosahedron, dodecahedron. A solid contains solid angles, and a solid angle cannot be constructed with 2 triangles or 2 planes. With the 3 equilateral and equiangular triangles, the angle of the pyramid is constructed. That is, the solid angle of the pyramid is constructed. With 4 equilateral and equiangular triangles, the angle of the octahedron is constructed. With 5 equilateral and equiangular triangles, the angle of the icosahedron has been constructed. Now, a solid angle cannot be formed by 6 equilateral and equiangular triangles placed together at one point. Why? Because we know an angle of an equilateral triangle is 2/3 of a right angle, which is 60 degrees. 6 equilateral triangles would make it 4 right angles, that is 360 degrees. And we have already seen that it is not possible to construct a solid angle, since a solid angle is contained by plane angles adding up to less than 360 degrees. Here it is becoming equal to 360 degrees. Now, a solid angle cannot be constructed by more than 6 plane angles, since the sum of the plane angles would become greater than 360 degrees. A solid angle of a cube is constructed by 3 squares perpendicular to each other. That is 3 times 90 degrees, which is 270 degrees, which is less than 360 degrees. So, yes, but it is not possible to construct a cube by 4 squares, since the solid angle is equal to 360 degrees and it should be less than 360 degrees. Solid angle of the dodecahedron is contained by 3 equilateral and equiangular pentagons. The angle of each of the angles of the pentagon is equal to 1/1/5 of a right angle, that is equal to 180 degrees. And we will prove this as part of the lemma later. So it is not possible to construct a dodecahedron with 4 equilateral and equiangular pentagons, since solid angle is equal to 4 times 108 degrees, which becomes equal to 432 degrees, which is not less than 360 degrees. Similarly, a solid angle will not be contained by other polygonal figures for the same reason. Okay, now let's look at the lemma. So, what do we have to prove as part of the lemma? That an angle of a pentagon, equilateral and equiangular pentagon, is equal to 1/1/5 of a right angle. Let QRSTU be an equilateral and equiangular pentagon. Circumscribe a circle QRSTU on the pentagon QRSTU. So let's draw the circle. Take the center as Z. Draw QZ, RZ, SZ, TZ, and UZ. So basically join the various vertices with the center. These segments bisect the angles of the pentagon. So each of these segments will bisect the angles of the pentagon. The angle at Z is going to be 360 degrees. So which means angle QZR, we can take any one of these angles. I'm taking QZR. So angle QZR is equal to 1/5 of 360 degrees, which comes to 72. Let's take the triangle QZR. The angle QZR plus ZQR plus QRZ will be equal to 180 degrees. Angles of a triangle are equal to 180 degree. We already know that angle QZR is 72 degree and ZQR angle and angle QRZ, they are both equal because they are opposite to equal sides. ZQ is equal to ZR because they are the radii of the same circle. So that means we can write these two angles as 2 times ZQR equal to 180. Now let's subtract 72 degree from both the sides. We get 2 times angle ZQR is equal to 108 degree. So angle ZQR is equal to 54 degree. But remember, the segment ZQ bisects the angle of the pentagon, that is UQR. That means if ZQR is equal to 54 degree, that means ZQU will also be 54 degree. So therefore, UQR angle is equal to 2 times ZQR, which is equal to 180 and which works out to 1/1/5 of a right angle, which is what we had to prove. And since it is an equiangular and equilateral pentagon, all these angles would be 1/1/5 of 90 degree. That was the remark at the end of proposition 18 along with the lemma. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.